Dear students, Assalamu alaikum and welcome to e-learning Al-Noor International School, grade 11 chemistry course. I'm your chemistry teacher, Fraz Anjum. Today we will discuss chapter 19, acid, bases and salts, lesson 2, hydrogen ions and acidity. This lesson will continue next week as well. So 2-week lesson. In this week, we will study textbook page number from 653 till 657. So please open your textbook page number 653. Resources. You need textbook, notebook, calculator, and pen, pencil, etc. This week lesson objectives are: describe how H positive and OH negative ion are related in an aqueous solution, and classify a solution as neutral, acidic or basic by using pH. Let's start our lesson. Hydrogen ion from water. So for an aqueous solution, the product of the hydrogen ion concentration and the hydroxide ion concentration equals to 1.0 times 10 power negative 14. So what it means? The concentration of H positive ion, the bracket shows concentration, okay, remember this, plus OH negative ion concentration always equal to 1.0 times 10 power negative 14. So I can say like this as well, that only for hydrogen how much? So 1.0 times 10 power negative 7, and here same 1.0 times 10 power negative 7. When you add it, it becomes 1.0 times 10 power negative 14. Okay, so remember this equation for future calculation. Boys, you know this one, that water molecules are highly polar and are in constant motion even at the room temperature. Remember this, even on the room temperature as well, always in the constant in motion water molecules. On occasion, the collision between water molecules are energetic enough for the reaction to occur. Means because of this, water molecule can collide each other, okay, and reaction going to be take place. After the reaction, what going to be happen, that one of them, the molecules of water, donate or lose the hydrogen H positive ion, and other one is accepted. Suppose this water molecule lose one hydrogen, and who gain? This one, it become hydronium ion. So H2 already there, H positive gone there, it become H positive, H3O positive. Okay, so H3O positive is a hydronium ion. Okay, remember this. So hydronium ion means who accept the hydrogen, ion. So H2O plus H positive become H3O positive, which is called hydronium ion. Okay, now who lose the hydrogen? What left here? Hydroxide ion to become OH negative ion. Okay, so a water molecule that gains the hydrogen ion become a hydronium ion, H3O positive, and the water molecule that loses the hydrogen ion become a hydroxide ion. Okay, so this is the property of water. So in the water, always hydronium ion and OH ion present. Now, self-ionization of water. The reaction in which water molecules produce ions is called self-ionization water. Means like what we just said now. So H2O become H positive ion and OH negative ion. In an aqueous solution, the hydrogen ion are always joined water molecule as hydronium ion. Remember, last week we discussed as well that H positive ion itself, free H positive ion, never be in the H2O. It must be with H2O plus H positive become hydronium ion, which is H3O positive. Remember, okay? So in pure water at 25 degrees Celsius, the concentration of hydrogen ion is only 1 times 10 power negative 7 molar. M molar means molarity, okay, concentration. Okay, this is constant value, so remember this one as well. The concentration of OH negative ion is also same, which is 1.10 1 times 10 power negative 7 molar, because of the number of H positive always equal to OH negative ion, okay, in pure water. So any aqueous solution in which H positive ion and OH negative ion are equal is called neutral atom. Got it? So how we can say that this is neutral solution or neutral uh, water, that H positive ion or OH negative ion always equal. If both are equal, then neutral. Okay, remember. So if the concentration of H positive ion equal to OH negative ion in the solution, this solution called neutral solution. So what is ionic product constant for water? The ionization of water is a reversible reaction. So Le Chatelier principle applies here as well. Remember the equilibrium, okay? So adding either hydrogen ions or hydroxide ions to an aqueous solution is a stress on the system. And in response, this equilibrium will shift it towards the formation of water. Remember that reversible reaction always says that principle that the equation chemical in the chemical equilibrium always want to be stable. That if the reactant side is more, the reaction going to be shift on the product side, or if the product side is unbalanced, this shifted to the reactant side. Okay, so until the stability or the equilibrium going to be fixed. So in the response of equilibrium will shift toward the formation of water. The concentration of other ion will decrease. If any aqueous solution, when hydrogen ion increases, OH going to be decreased. Likewise, when H positive ion decreases, OH ion going to be increased. Okay, in the water, especially for the aqueous solution. So the ionic product of the concentration of hydrogen ions and the hydroxide ion in the water is called the ionic product constant for water, which shows by Kw. So Kw is equal to concentration of H positive ion times concentration of OH negative ion. It gives you 1.0 times 10 power negative 14. Okay. Now, acidic solution. In the acidic solution, when some substance dissolve in water, they release the hydrogen ion. Okay, acidic, you know, the as acid means donate the H positive ion. We discussed this last week. So HCl, if we break down, it gives you H positive ion and Cl negative ion. Okay, so this H positive ion, where it goes? Good, in the H2O molecule and become hydronium ion. So the hydrogen ion concentration is greater than the hydroxide ion in the concentration. So a solution in which H positive ion or the concentration of H positive ion is greater than the OH ion is called acidic solution. So the H positive ion is greater than 1 times 10 power negative 7 molar. Okay, always remember this, right? For the concentration of H positive ion always greater than 1 times 10 power negative 7, because if 1 0 times 10 power negative 7, this is called neutral atom, okay, or neutral solution. So it has to be more. When it's going to be more, it means more hydrogen ion present, and because of this more hydrogen ion, it become acidic solution. Let us start with the basic solution. When the sodium hydroxide dissolve in water, it forms the hydroxide ion in solution, such as NaOH. When it dissolve in water, Na positive and OH negative ion going to be separate out. Now, the hydrogen ion concentration is less than the hydroxide ion concentration because they dissolve NaOH and concentration of OH going to be increased here. So when the concentration of OH ion increases, it becomes basic solution. So a basic solution is the one in which H positive ion concentration is less than the OH. So OH ion concentration is more. So basic solution are also known as alkaline solution. Using the ionic product constant of water for water, if the H positive ion in a solution is 1.0 times 10 power negative 5, this is the concentration of H positive ion, remember. Is the solution acidic or basic or neutral? What is the OH negative for this solution? So let's start. What is given? The concentration of H positive ion. So H positive ion is equal to 1.0 times 10 power negative 5 molar. Okay, this is given. Kw always, it is constant value. Kw always 1.0 times 10 power negative 4. Now what is asking is the solution is acidic, basic or neutral, and as well as OH negative ion concentration. So let's start. H positive ion is 1.0 times 10 power negative 5, which is greater than the 1.0 times 10 power negative 7. Okay, it looks 7 is bigger, but remember the sign is negative. Okay, so that's why 1.0 times 10 power negative 5 molar is greater than the this. That's why the solution is acidic. So the formula, remember, Kw always equal to 10 H positive ion times OH negative ion, the concentration itself. Now we need OH negative ion now. Okay, what is it? OH negative ion needed. So this one is going down. Okay, crisscross like this. Now, so what will be the formula going to be for OH negative ion? OH negative ion is equal to Kw over H positive ion concentration. Put the values on it. OH is negative is equal to, what is the value of Kw? Remember, 1.0 10 power negative 14. So 1.0 times 10 power negative 14 over, what is the concentration? Is given in the question, 1.0 times 10 power negative 5. Okay, after calculation you get 1.0 times 10 power negative 9 molar. Okay, so this is the concentration of OH ion. How to calculate it? It looks like this. Now the pH concept. How is pH used to classify a solution as neutral, acidic or basic? So this is the scale. Remember this. A solution with a pH less than 7.0, sorry, less than 7.0 is acidic. Start from the 0 till less than 7.0. Okay, is acidic. The solution with the pH of 7.0 is neutral. Means around 7.0 is neutral. Okay, 7.0 is neutral solution. If the solution with the pH greater than 7, means more than 7 till 14, this is called basic solution. Understand? Remember, this is important thing. Okay, now hydrogen ion and pH. The pH of the solution is the negative logarithm of the hydrogen ion concentration. Okay, this is the definition of pH. So what is the formula? pH is equal to negative log H positive ion. This is the formula how to calculate the pH. So in pure water or a neutral solution, the pH always equal, the concentration of H positive always equal 1 times 10 power negative 7 molar, and the pH is 7. Okay, pH is 7. Okay, so how? Let's see. pH is equal to negative log, okay, H positive ion concentration. So H positive ion concentration is 1.0 times 10 power negative 7. Put here negative log 1. Okay, log 1 always 0, remember this. And log 10, okay, is equal to always 1. Log 1 0 and log 10 always equal 1. So when you calculate it, it become 7.0, or you can do directly in your calculator to use the function log. You will get 7.0. So the pure water, the pH of pure water is 7.0. Here we go. This is the hydrogen ion and pH. Look here, the pH start from the 0 till 14, and this is the 7.0. So when the 7.0, any solution in the 7.0 range, this is neutral. What is it? Neutral. So check here, pure water is exactly the 7, okay, and blood this side little bit basic, and milk upper side little bit acidic. Now, so when you go less than 7 this side, like a 6, 5, 4, 3, 2, 1 and till 0, this is said to be more acidic. This is said to be more acidic. And if you go 7 to 14, it's said to be more basic. So basicity increasing here and acidity increasing this side. See, increasing acidity and increasing basicity. So if I say the which one is a more stronger acid, 0.4 pH or 5.4 pH. So 0.4 pH are more stronger. Okay, if I say which one is a more stronger base, 9.5 value of pH or 13.5. So definitely 13.5. Okay, so this side more basic, more strong base, and this side more strong acid, and these are the concentration. Now calculate the pH from H positive ion. What is the pH of solution with the hydrogen ion concentration of 4.2 times 10 power negative 10 molar? So in data, hydrogen ion concentration is given, pH is asking. Formula, you know this, pH is equal to negative log H positive ion. Just put the value here, and in the calculator you can do it. Just type negative function log, write the value, equal, you will get the answer 9.38. Okay, let me know boys, what is it? 9.38 pH means acidic or basic? Perfect, basic. Thank you so much, and we will continue inshallah for next week.